Good morning, geometry. All right, I'm going to show you a problem that I will pose for a quiz, and it looks something like this. You're given this triangle ABC. You're given the measure of angle A. You're given the length of side A, and you're given the length of side B. I would like the length of side C, the measure of angle B, and the measure of angle C. I'm going to get rid of that. So, and I want the area of this also. Let's just make it even more fun. So I need all 6 pieces, and I want the area. Well, let's start with the area. Let's see if we can't do something with that. So here are your 3 versions of your area formula. And if I know the measure of angle A, to make that equation work, I need the length of side B and C. I don't have C. Now that one's out. Okay, the next one, I have the length of A and B. So if I go down here, that says that I need the measure of angle C, which I don't have. So this does not seem to fit any of these formulas that we have. So now we've got to go out and find some pieces. To use the sides we have, we need the measure of angle C. To use the angle we have, we need the length of side C. So what can we do? Well, fortunately, you are armed with something called the law of sines. The law of sines says that A over sine A is equal to B over sine B is equal to C over sine C. So long as your triangle, if you have a pairing of an angle and a side opposite, you've got it. You can do all of this. So there it is. So I'm going to plug this in. Notice sine C doesn't do me any good at all. So I'm going to focus on that part of it. And if I do the plug in here, I get 9.33 sine B is equal to, cross product. And C, and I come down here, and finally, sine B is equal to 0.681568. Now, that's a lot of decimals. Now, remember, I need the measure of the angle. That looks like sides to me, so I'm going to use my inverse sine key. I'm going to go sine inverse 0.68156, and the measure of angle B is 42.97 degrees. So let me go through how we found the measure of angle B again. We went through here and we used the law of sines. We took the information that we had, we set it up, we cross product, we found that sine B is equal to 0.681568. Now that is what that inverse sine key will do for you. It can convert the sine of the angle to the actual measure of the angle. So inverse sine 0.681568. And remember, that's your second key and then sine. So now that I know the measure of angle B, I can definitely find the measure of angle C, because I know the interior angles of a triangle add up to 180 degrees. So 180 minus the 32 plus the 42.97, and the measure of angle C is 105.03 degrees. And look at that. What jerk did not even attempt to draw that triangle to scale? Well, that would be me, folks. So don't be surprised. All right? All right, so now I know the measure of all 3 of my angles. So I could write that in, all right? And we will here in a minute. So now, can we find the area? Yes, we can. So now I can say that the area is equal to 1/2 12 times 9.33 times the sine of 105.03, and the area is 54.065 square units. Okay, all I need now is the length of side C. Remember that version of the law of cosines we had that said that C squared is equal to A squared plus B squared minus 2AB cosine of the angle C? Well, we have all that now. So I set that up, and C squared is equal to 289.11, or 17. So now we have found all 6 of these pieces. We have found them all. I know that C was 105.03. B was 42.97. Oh, that's a terrible 4. And then C is 17 degrees. All right, so when I ask you on your super fast coming chapter 9 test, I will give you problems like this, and I'll say, here you go. I want all 6 of the components, and I want the area. And that's what I'm going to do, all right? And then just for a little proof in the pudding here, I popped this up on GeoGebra for you, and it all came out pretty good. Anyway, there you go, folks.